Today we're going to talk about the linear equation. We're going to speak on what it is, the properties of it, and how to use it. So to start with, I want to write out the linear equation. This is a good baseline for what is to come. And the base equation that you'll probably see in your textbook and from your teacher is y equals mx plus b. Now, if you haven't worked with equations before, that's going to seem slightly confusing to start with, but we're going to work on it and it's going to make sense in the end. So let's look at this equation and break it down. When we're looking at y equals mx plus b, there's a couple things we want to note. X is going to be our input. M and b are descriptions in the equation, and y will be our output. And we can see that represented when we look at this plot. We're going to have x and y, so we'll provide an x value and we'll get a y value as an output. Now looking at this, we know what x and y will be in respect to this equation, so let's look at m. M right here we're going to refer to as the slope of the linear equation. And what the slope is we're going to look at this line here, and we're going to note how we move in two directions. We move across the x and we move across the y. When we move, we call that a change. So we can denote this change with a triangle, we call it delta. And for y, it's going to be delta y. And for x, it's going to be delta x. So you're going to see these triangles right next to x and y. All that means is the change in x and the change in y. When we see change, that means going from one point or one position on the graph to another one. The other important detail to note in the linear equation is b. Looking at b, b is what we call the y-intercept. And that is going to be the point where our linear equation line meets the y-intercept. And the y-intercept is the line that we denote commonly with y when looking at graphs. So we know that the horizontal axis here, we call it an x-axis, and that the vertical one we call a y-axis. So wherever this point is that the line for the linear equation will touch, we're going to call that the y-intercept. So if we know the slope, we know the y-intercept, we can input an x value to get a y value. Now what that looks like, when I mean input, say we have an x value of 1. Okay, now when we look at this line, we're going to draw a straight up line from the x and draw that straight to the y. This little question mark where I got here, when we have all the m and b and then we input an x, we're going to get this y value that corresponds to the given line. So it's a little confusing to start with, and that's understandable, but what I want to focus on is some examples, as that's probably the best way to describe the linear equation, and it makes more sense when you get into it. So let's look at this example here. So we have the point 0, 1, and we have the point 2, 2. What we're going to do is we're going to draw a line that passes through both these points. And that is our linear equation line, or linear regression line. And with this, we can write out the base equation, y equals mx plus b. And with that in mind, we're going to look towards filling that equation in, and that's going to tell us a couple things about this equation. So to start with, I would look at the slope. Now we spoke that the slope, or m, in this equation is known as the change. Now when I say change, what we're meaning is the change in y divided by the change in x. And that's going to give us a slope, how much something increases in a certain direction while also moving in one direction. So in this case, we're looking at how much it changes in y as we change in x. And if you've never done this before, it might seem slightly confusing, and that's understandable, but when we look at change in y and change in x, it's not too difficult once you got some experience. So we're going to write out first our points that we're working with. We're working with 0, 1, and we're moving to 2, 2. I'd always write it like this, especially when you're starting. We know that the change in y, let me write here, we got x1, y1, and then we'll call this x2, y2. Just saying they're two different points. So when we're looking at the change in y, we want to see how you've changed going from y1 to y2. So you can take y2 minus y1, so the second point minus the first point, and we're going to divide that by the change in x2 minus x1. So plugging this in with our given points will make a little more sense. Now we know that y2, looking at this, is 2, and y1 looking at this is 1. Now we're going to divide that by x2 minus x1. x2 is 2, x1 is 0. So let's simplify that. 2 minus 1 is 1, 2 minus 0 is 0, and now we come with 1/2. That's going to be set equal to our m variable in the linear equation. Now with that in mind, we have to figure out what b is. B, we referred to earlier, is the y-intercept. So let's label that quick in this equation here. We're going to call that the y-intercept. And in some cases, in an example we'll look at later, you'll have to solve for the y-intercept. But for now, we can see that this first point, 0, 1, falls on the y-intercept because we're at x equals 0, which is where the y-axis falls. So we know that b is 1. So we can just note that b equals 1. And let's just draw a little arrow to signify where that came from, because we see it falls on the y-axis line right there. So now that we have m and we have b, let's plug it into the equation to get the final equation. So we know m is 1/2. We used our equation up here to find that. We're going to put the x in front of it, meaning 1/2 times x. And we're going to add b, which we found to be 1. So our equation in the end is y equals 1/2 times x plus b. Now I want to plug in a couple of x's just to show how this equation works. Let's say x equals 1. So we're going to plug that into our equation. We still have y. We're looking for y here. We're going to have 1/2 times 1. We plugged in our x equals 1 for the x in the equation. And then we still have a plus 1 at the end. And that's going to be y equals 1/2, because 1/2 times 1 is just 1/2, plus 1, which equals 3/2, or 1.5. Looking at the graph here, let's make a point at x equals 1. Draw that straight up to the line and draw a horizontal to the y right there. And we're going to see this point right here is 3/2. So that's how the linear regression line works. Once we have the attributes, we can plug in an x and get a y out of it. Let's look at another example. Let's say x equals something larger, maybe like 5. Let's put that into the equation. Substitute it for x. And that's going to be y equals 5/2 plus 1, which goes to y equals 7/2. That would also be 3.5. Okay, so look at here. Let's say x equals 5 falls about here. Seems pretty close. Let's draw a straight up line touching the linear regression, linear equation line. Then have that go over to the y-axis. And right here, we're going to have 7/2. So once you have m and b, you can plug in x to get a corresponding y, or if you have a y, you can solve for x, which we may see in a future example here too. So that was a basic example, and I like to think that as basic because you're giving the y-intercept, so you don't have to solve for it. Now you're going to have some examples like this. You can see you have 2 points here, but neither fall on the y-intercept. So with that in mind, you still have to solve for it. You need to understand what your equation is. So let's say we have this line. It's going to reach out. That's a straight line there, going through both 2, 3, and 7, 1. And that's going to go infinitely in this direction. Okay, so I'd say a great first place to start again is writing out the base equation, y equals mx plus b. And just like the last one, I would recommend solving for the slope first. This tends just to be easier. So we know that the slope is a change in y over a change in x, which just means y2 minus y1 over x2 minus x1. These little subscript numbers here just mean 0.2, 0.1, nothing more than that. So let's write out our points right next to this. We had 2, 3, and we're going to be moving over to 7, 1. Okay, so we can call this 0.1 and 0.2. Looking at that, let's look, y2 would be 1, we get that from 7, 1, minus y1, which would be 3, and that's going to be over x2, which is 7, minus x1, which would be 2. Okay, so 1 minus 3 is negative 2. We're going to divide that by 7 minus 2, which is 5. So our slope is negative 2 over 5. Now, an important distinction to make here is that this is a negative slope. A negative slope means that it's moving downwards. So we can draw a little example up here. Let's say our negative is in green and our positive is in red. A positive slope will move up and to the right. Negative slope will move down and to the right. So as you go right, negative moves down. As you go right, positive moves up. So here we can see I have a negative slope, and that tracks with the graph as it's moving down as we go right. Now that we got the slope, we can't just pick it out of the graph when we're looking at the y-intercept. So rather than that, I'm going to recommend writing the slope in the equation first, and then still have b for the y-intercept because we don't know it yet. Now, a trick to know the y-intercept when you don't have to look at it is taking one of your 2 points. So we have 2, 3 or 7, 1. I'm going to use 2, 3 just because they seem to be smaller numbers, and that just typically makes for easier math in the end. We're going to plug those points into the linear equation. So let's say we're working with 0.23 here. Now we know 2 is the x, 3 is the y. We're going to plug that into the linear equation that we have found so far. So let's say y is 3 according to those points. We're going to substitute 2 for x. And then we're still going to have plus b because we don't know the y-intercept yet. So let's keep solving this. 3 equals negative 2 over 5 times 2 is negative 4 over 5. Then we still don't know b. To get negative 4 over 5 to the other side, because we want b to be by itself, we're going to add plus 4 over 5. And here we got a little bit of a fraction issue, but that's no problem. Let's say 3 is equal to 15 over 5, so we have the same fraction. And we're going to be adding 4 over 5. And what that is going to lead us to is a b value of 19 over 5. So now we're going to look at all this in mind and write out the final equation. So we have y equals our m value, which in this case was negative 2 over 5, times x, plus the y-intercept, or b, which we found through our solving right here, to be 19 over 5. So that's a little more of a messy example, but it's important because you're not always going to get clean numbers when working with these. So we can look at the graph just to make sure that this seems to be correct in the end. Okay, this is saying that we have a negative 2 over 5 slope, which we see we have a negative slope. As we go to the right, we move down, and that we're going to have a y-intercept of 19 over 5, which is about 4. And seeing that this is 3 right here, that looks to be correct. So with that, we could plug in a couple numbers. Let's just say we're going to work with x equals 1, just make it a simple example. That's going to say y equals negative 2 over 5 times 1 plus 19 over 5. And that's going to be negative 2 over 5 plus 19 over 5. We're just saying y equals 17 over 5. So if we're going to look at our graph here, what that is going to seem like after we plug it in is saying that x equals 1. Say that's about here. We're going to connect that to the line here and go over. And we're saying we have about 17 over 5 as this y value. A final detail that I wanted to mention is normally when it comes to the linear equation, we're plugging in an x value and we're getting a y value in return. However, using algebra, you can work in the reverse order. You can start with a y value and want to find what x value will give you that y output. So looking at this example, we have y equals 2x plus 1 as our linear equation. That means we have a y-intercept of 1, which we can see here as it touches the y-axis. And we have a slope of 2, which is a change of 2 in the y for a change in 1 unit of the x. Now let's say we wanted to find what x value gave us a y output of, let's say, 11. So we can plug in y equals 11 into our equation here and just have the rest of the equation in mind, 2x plus 1. And then using algebra, we can solve in reverse here. So we know that we have to get this 1 to the other side on the left first to isolate the x. 11 minus 1 would be 10. We're going to set that equal to what's left, which is 2x, as this 1 cancels out here. And since we want 1x and not 2x, we're going to divide each side by 2. We have that 5 equals x. So this means that an input of 5 for x gives us an output of 11 for y. And we can just plug that back in to check quick. Let's say we have y equals 2 times 5 and then plus 1. 2 times 5 is 10. So plus 1. And that does come out to y equals 11. And let's look at one last example here. Say that y equals maybe 17. So we have 17 equals 2x plus 1. We're going to have to get that 1 to the left side, so we're going to do minus 1. And we have 16 equals 2x here. We want 1x and not 2x, so we're going to divide by 2. We're going to have that 8 equals x. So we can see, looking at this graph here, that an x value of 5 gives us a y value of 11, and that an x value, let's say 8 falls there, gives us a y value of 17. So as long as you have the linear equation all laid out, you have m and b. If you have a y in mind, you can work with algebra to figure out what x will give you that y value. As a recap for the linear equation, we have the equation y equals mx plus b. Through our examples, we saw that m is represented as the slope, which is the change in y over the change in x for this linear regression line, which is going to pass through 2 or more points. And the y-intercept, we recognize it as the b of y equals mx plus b. And the y-intercept is where our line touches the y-axis, which falls at x equals 0. When we have m and b, we can plug in an x value, and that's going to give us a y value as an output. We can see this represented as x equals 1 down here on the graph. We're going to draw a line up to the linear regression line and go directly left, and that's where our y value output is going to be. So I hope you guys enjoyed the video. If you have any questions at all, feel free to drop them in the comments. I'll be glad to answer. Share this with your family, your friends, those that might need it for help with their math. Other than that, like the video, subscribe, and I hope to see all you guys in the next one. Thank you.